Hey guys, this is CHEMPLIFIED, and in this video we will talk about aldol condensation. Now before we start the video, let me tell you that this term aldol is made up of two different terms. The ALD represents aldehyde and OL represents alcohol. So OL is from alcohol and from aldehyde you have ALD, right? So you will get aldol. It simply means in the final product you will receive an aldehyde and an alcohol functional group in the same compound. So let's start the video. Now before we continue, what is going to happen in this reaction is written in this statement. Aldehyde containing alpha hydrogens undergo self addition in presence of a base to form a product called aldols. The reaction is called aldol condensation. The term, I have already told you, the term aldol is derived from the combination of two words, aldehydes and alcohols. The two functional groups are present in the product. Now before we continue, what is alpha hydrogen? What is alpha hydrogen? Suppose there is a functional group. This is your functional group aldehyde, right? Now there will be a carbon next to it. The hydrogen present on that particular carbon is alpha hydrogen, and the carbon, this carbon is known as alpha carbon, and the hydrogen present on this carbon is alpha carbon. Now suppose there is second carbon. This is your aldehyde group. This is first carbon, this is second carbon. So the second carbon is known as beta carbon, and the hydrogen that is attached to it is beta hydrogen. So in this particular case, what we need is alpha hydrogen, right? So let's just write down the reaction or the chemical equation. There are two aldehyde molecules which will combine together in presence of a base. So in place of base, I will just write OH minus, OH negative. And what will be the final product? Just look at it carefully. You will get CH3COH, CH2, C double bond OH, right? So the name of this compound will be 3-hydroxybutanol. Now this is your aldol. If you look closely, there are two different functional groups. This is your aldehyde functional group and this is your alcohol functional group in the same compound. Now why the name is 3-hydroxy? Because this is our prior functional group. Aldehyde is our prior functional group, then alcohol. So you will start the numbering from this carbon 1, 2 and 3. So 3-hydroxybutanol, right? This will be your chemical reaction for aldol condensation. And now is the time for the mechanism of aldol condensation. Really important topic, mechanism of aldol condensation. What is the first step? The first step is the creation of enolate ion. The first step is the creation of enolate ion. How this is going to happen? The OH minus has a negative charge. What this OH minus will do is, it will attack the hydrogen opposite to the functional group, or alpha hydrogen. This is your alpha carbon. So the hydrogen attached to that carbon is alpha hydrogen. Alpha hydrogen will be taken out and you will get an enolate ion. The structure will be like this. There will be a negative charge on the carbon, plus formation of water. Why? Because this is OH. OH plus H gives HOH, also known as water, right? So this is your first step. Here this is your enolate ion. Now this enolate ion will be your nucleophile. What is nucleophile? Nucleophile is that atom or ion that has the ability to donate electron pair. Now this is there is an extra electron on this carbon, so this carbon will be able to donate its lone pair to some other electrophile, right, or some other polar entity. So in simple terms, this will be your nucleophile. this will act as nucleophile. Now what will happen in the next step? Just before we continue, remember that carbonyl group is polar in nature. Why? Because oxygen is electronegative, so there will be a delta negative charge, and on carbon there will be a delta positive charge, right? And this nucleophile will attack the positive charge. This is going to happen in the next step. Let's take a look. Now in acetaldehyde, remember in the starting material in our reaction, we have two acetaldehydes. We have two molecules of acetaldehyde that will participate in the formation of aldol. So first one, what the first one did is, the first one provided with H plus ion and created a nucleophile. This second one will be treated with this enolate ion, and the lone pair will attack the carbon having positive charge, small positive charge. Now as soon as it attacks the carbon, the electron on the double bond will move towards the oxygen, and the product that you are going to get is CH3, C, O negative, right? H will be there, O negative, H, then this enolate ion will be there as it is, CH2, C double bond O and H. This is your second step, right? This is your intermediate form. Now it only needs one H plus ion to be attached to this oxygen. We will do this in the third step. From where we are going to get our H plus ion? From the water molecule. We will get our H plus, this will create H plus, or the negative ion will attack the hydrogen, and electrons will move towards the oxygen, giving OH minus back. So the final product will be CH3, C, OH, CH2, C double bond O, H. This will be your final product, single bond. This is your aldol. We have already written the name previously, and you will get back your OH minus. Now look at it carefully. In the first step, OH minus was reacting with aldehyde, acetaldehyde. From where you get this OH minus? In the statement we have already written that there is a base. In presence of a base, there is a base which will provide you with OH minus, and the same OH minus will attack the aldehyde group, and in the last step you will receive your OH minus back. In the step 3 of the mechanism, you will get your OH minus back. So the base which is present in the solution will not be affected, right? So this is your formation of aldol, and the whole process is aldol condensation. Now this was the equation for aldehydes only. Now before we go for ketone, also remember that aldols are easily dehydrated. What is the meaning of dehydrated? Dehydrated simply means water molecule moving out. How they are dehydrated? By heating or by treatment with dilute acid to form alpha beta unsaturated aldehyde, right? So let me write down the reaction. Let's start. You will get CH3. As soon as you heat it out, water molecule will be removed. Which water molecule? OH and H. What happens when you remove it? You will get a double bond, right? And aldehyde will be there, CHO. Now why this is alpha beta unsaturated? This is the product is alpha beta unsaturated aldehyde. Why? Because alpha and beta carbon are making a double bond. So unsaturation is at alpha and beta position from aldehyde group. So this is your alpha beta unsaturated aldehyde, right? So this is the product of dehydration of aldols. Now let's move to ketones. Just like aldehydes, ketones will also give your aldol reaction and form ketols. We call them ketols because we are making it from ketones, and because in the final product you will get a ketone and a alcohol. Now let's read the statement. Ketones containing alpha hydrogen, condition is still the same. Ketones containing alpha hydrogen also undergo aldol condensation to form ketols. For example, two molecules of acetone. In this process also you will require two similar or different molecules of ketones combined with each other in the presence of barium hydroxide to form 4-hydroxy 4-methyl 2-pentanone. Right, let me write down the final product. Just like the previous one, this will be converted to alcohol and this will be your ketone as it is. Just like the previous one, the some base will be there which will take out the hydrogen. In this case, what we have is, where is that? Barium hydroxide. We have barium hydroxide. It will take out hydrogen, create a nucleophile. This nucleophile will then attack this carbon and make alcohol. Right? So the final product will be like this: CH3, C, OH, CH3, CH2, C double bond O, CH3. Now if you look at the naming, the name is already given. The prior functional group is ketone. So 1, 2, wait a second. Sorry, a small mistake. The prior functional group is ketone. So the numbering will start from this place, closest to the functional group. 1, 2, 3, 4. Right? This will be the position and this will be your fifth. Now the naming will be 4-hydroxy, 4-methyl and 2-pentanone. On fourth position there is hydroxy group and on fourth position there is methyl group, and there are total 5 carbons in the chain, so you will write the name pentanone. I hope you understood. The mechanism will remain the same, just in place of aldehyde there will be ketone. Right? Now next is ketols are also dehydrated by heating or by treatment with dilute acid to form again alpha beta unsaturated ketones. They will form alpha beta unsaturated ketones. Let me write the final product. This water molecule will be removed. Right, there will be double bond formation just like the previous one, and you will get this compound. This is your methyl oxide, or you can write the IUPAC name and remove water. You can write the IUPAC name 1, 2, 3, 4 and 5. So you will write 4-methyl 3-pentene 2-one. 4-methyl 3-pentene 2-one. This will be your IUPAC name for the above compound. Right? So this was your aldol condensation and a few reactions and the reaction of dehydration of aldols or ketols both. Right? So this will be it for today's video. Thank you very much for watching.